How do you take a raw water which might look like this and turn it into a clear drinking water? And how can we know if it's guaranteed safe to drink? In this module, you'll learn about the different water treatment processes and technologies involved in ensuring the safety of drinking water supplies. Treatment technologies make up the fourth functional group of full water supply system. After this module, you'll understand the role of this functional group, recognize the three categories of treatment processes, and be able to assess the advantages and disadvantages of some of these technologies. These processes can be grouped into technologies that clarify the water, remove or inactivate microorganisms, treat geogenic, organic, and inorganic contaminants, and/or desalinate the water. The choice of which treatment process to use is influenced by the quantity and quality of the water source. Depending on the location, water resources usually contain dissolved or particulate matter and gases as a result of interaction with the atmosphere, minerals from rocks, and natural organic matter, and macro and microorganisms. Anthropogenic activities can further impact the quality of these water resources. Boiling water with fuel is the oldest and most commonly used method worldwide for treating small quantities of water used at the household level. Boiling inactivates all microorganisms but does not remove turbidity or chemical contaminants. There is also solar disinfection, or also called SODIS, which inactivates microorganisms through a combination of UV irradiation, visible light radiation, and heat. These methods offer the advantages of high user acceptance and ease of use, but on the downside, treated water may be vulnerable to recontamination, and boiling is also very fuel intensive. Chemical treatment includes coagulation, flocculation, and precipitation, adsorption, ion exchange, and chemical disinfection with germicidal agents such as chlorine shown here. The advantages of these chemical treatment methods are that they are relatively low cost, and in case of chlorine, provides residual disinfection to protect against recontamination. However, chemical methods may not be accepted by some users, and establishing supply chain can be challenging in some areas. Finally, there is biological treatment, which involves a biologically active layer that forms during filtration that supports the removal of pathogenic microorganisms. An example of biological filtration technology is the Biosan filter shown here. This method is a low-cost and simple to operate and maintain. However, like physical methods, there is a risk of recontamination post-treatment. Some technologies harness more than one treatment process for removal of problematic contaminants. For example, the Sono filter, shown here, is widely found throughout Bangladesh. This filter uses two-bucket system to combine chemical and physical treatment processes to effectively remove arsenic from drinking water. In summary, treatment technologies make up the fourth functional groups of a water supply system. You have learned about three treatment processes used to remove various contaminants categorized broadly as physical, chemical, and biological treatment. We briefly covered some of the advantages and disadvantages of these processes. For example, residual disinfection to protect against recontamination is an advantage of chemical treatment and a challenge for physical and biological treatment. Finally, this module gave an overview of various treatment technologies options that make use of each process, including some of the technologies like Sono filter that harness multiple processes for more effective contaminant removal.